There's a rock. The question says, two men are trying to move a heavy rock, as indicated in the diagram. And let's say, this is the horizontal line here. There is one force that is acting on that rock in this direction. Is that correct? In which the angle here is given to you and it's going to be 70 degrees. This one is 70 degrees and the magnitude is 50. F1 is equal to 50 Newton. Are you with me? There is another force acting on that rock. Let's take it here. And it's pointing 20 degrees to the negative x-axis, like you can see there. More or less there. Alright, this one is not accurate, but this is the drawing for you to get an idea. So this one is F2 equal to 40 Newton, and this angle is 20 degrees. We have to get the components, the resultant of those two forces. We're going to use another method called component method. Alright, so we're going to do a rough drawing of these two forces in a Cartesian plane. So now what we're going to do? None of those two vectors are on the axis. Therefore, we have to get the components for each of them. Do you understand? Alright, so let's do it. I'm doing it roughly. We don't have to do this one accurately. I'm going to take F1 and I'm going to take it to the Y because we are going to do calculation just now. So I'm going to do the same with F2. Okay, so what are we going to do now? We are going to calculate the component for each of them with the formula I just showed you. It's mathematics, okay? So let's start with F1. F1 in X. So F1 in X is going to be equal to F1 multiplied by cos theta is how much? 70 degrees. So let's do it. Let's do it real fast. .17 Newton. What is the direction? Positive x-axis. You need the direction. That's why I show you the rough drawing. Okay? So to the positive x-axis. Now we're going to do the same with F2 in X. Let's calculate the x's first. .38 Newton. What is the direction of that one as well? That's why I did the rough drawing here, so you can see it. It's to the positive x axis. Are you with me? Now I'm going to do the same for the y components of both of them. So F1 is equal to F1 sine theta. Theta is how much? Let's use the theta. It's 70. Okay? 47? 47 Newton. It's right up. Okay? Let's do the same for the F2. Direction? Look, no, that is why I didn't draw it. Negative, you see it's pointing down here. You see, that's why the drawing roughly is important, because you can get confused. So this one is to the negative. So if you want to, you can write down if you think you're going to get confused. It's fine. So now all we have is two forces in X and two forces in Y. So now we're going to calculate the resultant in X and the resultant in Y. F R in X is equal to F1 in X plus F2 in X. Both of them are positive. So I'm coming here and I say fr in x is equal to what we get. $55 Newton. What direction? Positive x axis. This is also important. Let's go to do the same with the y-axis. Okay? Let's do the same with the y-axis. Now for the y-axis, we have one pointing up, one pointing down. Alright? Even though we use positive y and so on, let's say a positive, so you don't get confused. Okay? So resultant force in the y-axis is equal to F1 in y plus F2 in y. Okay? F1 is positive, F2 is negative. Do you understand? Are you sure? Okay, so Fr in y is equal to positive is the 47 and the 14 is negative. So it's 47 minus 14. How much is Fr in y? How much you get? 33. 33 Newton. In what direction? It's a positive answer, eh? And I say positive is up. Can you see that? So I'm going to write here up, even though we're speaking about positive x and y. Do you understand? So what do I have now here, guys? A rough drawing again. I have 33 up. This one is Fr. Let's move it there. This one is Fr in y. And I have 55 in this direction. This is 55 Newton. And this one, let me just fix that one. That doesn't look nice there. This one is Fr in x. So the resultant vector will be that one there. That is what we are looking for. So how do we get that one now? Pythagoras. Fr square is equal to Fx square plus Fy square. That is Pythagoras. Are we done? No, we need the direction. How are we getting the direction? With the tricks. Here is the angle I want, that angle I want. So tan theta is equal to Fr in y divided by Fr in x. (31 degrees). Theta is 31 degrees. Guys, this is how we use this method to get the final answer.